This is the solution video for problem set 9, problem 2. And in this problem, we need to decide whether or not the state machine below, shown here, we have the 4 state bubbles and their timing diagram. We need to determine if this is a Mealy or Moore machine. And the first part of this basically is just the solution strategy. If you write the solution strategy, you've solved the problem pretty much. And so really there's nothing really more needed. So how do we go about solving this? What do we know about Mealy and Moore machines and their timing diagrams that can help us solve this? Well, basically the definition of a Mealy machine is that the output is a function of both the current state and the inputs. And a Moore machine is defined as a state machine where the outputs only depend on the current state. And so basically the question is, can we build a combinational circuit that will be able to do combine Q1 and Q0 to solve for Z? So if at any point, like, let's suppose we have two parts of the timing diagram that have the same state encoding, like 1, 1, they both are 1, 1, or both 0, 0, then Z should be the same for both. And that should be the case for every single thing. If on any one case that 0, 1, or 1, 1, or 1, 0, or 0, 0 is not enough to explain the output Z, but X does help explain the output Z, then we know this is a Mealy machine. And so basically we'll go clock edge by clock edge, and basically check to see at each stage whether or not we have two states that are the same, and if Z depends on both the state and X. So here we've got 0, 1, and so we'll go through each here. This is 1, 0, 1, 1, 0, 1. Okay, so we have 0, 1 twice. And so we look down at the output Z, and lo and behold, Z doesn't match. Z isn't just dependent on Q1, Q0. If you go up to X, well, it just turns out that Q1, Q0 with X equals 0 gets the output Z, 0, and Q1 is 0, Q0 is 1, and X is 1, ends up outputting Z. So we know this is a Mealy machine. And then the next part is basically we want to use this timing diagram to complete as much as possible of this state diagram. And so since we need to define our inputs and outputs, so we'll have X/Z for our input output. And so we'll come here. We're in state 0, 1, so we'll want to start here. And we have input 0. So when we get 0, we're going to be outputting 0. And we're going to want to go to 1, 0. So this is 0/0. And now we're at state 1, 0. 1, 0 with an input of X. Output Z is 1. So, and we're going to go to state 1, 1. So this goes to here. Oh, X is 1. Z is 1. Now we look at this. We're in state 1, 1. Our input is X. Our output Z is 0. So, and this takes us back to 0, 1. So this goes back up to here, 0/0. And now we are in state 0, 1. And we get another clock edge. And that takes us to 0, 0 when X is 1 and Z is 1. So 0, 1 goes to 0, 0. And we've got 1/1. And now we finally have one more arc transition. We don't know where it's going, but we do know how X and Z are related. And so this is going to who knows where, but we do know that when X is 1, Z is 1. So 1/1. And that is as much information as we can derive from this timing diagram. So moving on.